You're stranded on a remote island. One of your group is badly injured. The wound is infected. You've scavenged for mold, hoping to recreate penicillin. But now you face a critical question. How do you know if you've found the right mold? Not all mold is helpful. Some might save a life. Some might take one. What you need is the power to see what the naked eye can't. What you need is a microscope. The microscope is one of the most important inventions in medical history. It pulled back the veil on a world teeming with life, a world we couldn't see, but which was all around us. In the late 1600s, a Dutch textile merchant named Antonie van Leeuwenhoek began experimenting with magnifying lenses. He wasn't a scientist by training, he just wanted to see the weave of cloth more clearly. But what he discovered went far beyond fibers. Using tiny, handcrafted glass lenses mounted in simple frames, Van Leeuwenhoek peered into water droplets and scrapings from his own teeth. What he saw was astonishing. Tiny organisms swimming, squirming, alive. He called them animalcules, and unknowingly became the first human to lay eyes on bacteria and protozoa. But for nearly 200 years, microscopes had a big problem. The images often looked blurry or had strange color edges. That's because early lenses didn't bend light perfectly, which made it hard to see small details clearly. Then, in the 1830s, a British surgeon named Joseph Jackson Lister figured out how to fix this. By carefully combining two lenses, he reduced the blurring and color distortions. His work made microscopes much clearer and more powerful, setting the stage for modern microbiology. Without Lister, we wouldn't have seen bacteria clearly. Without van Leeuwenhoek, we wouldn't have known they existed at all. Back to the island. In this survival scenario, a microscope could mean the difference between cultivating life-saving penicillin or growing something deadly. But you don't have a lab, just wreckage, jungle, and ingenuity. A microscope needs just two things: a lens that can magnify, and a way to focus it. Start with the lens. Search the wreckage. Broken cameras, smartphones, eyeglasses, or binoculars might contain usable glass or plastic lenses. Even a water droplet can bend light and act as a simple magnifier. You can create a droplet lens by placing a small bead of water on a clear surface, like plastic or glass, or melt a bit of plastic from a water bottle and stretch it to form a curved surface. These won't be perfect, but they can magnify up to 10 to 20x, enough to distinguish bacterial colonies from mold spores. Next, you need to mount it. Use bamboo, coconut shell, or wire to create a frame. Position your lens above your sample and adjust the height until the image becomes sharp. The sample can sit on a white shell, a rock, or a clean scrap of plastic. Use sunlight or reflected light to backlight the sample. Adjust your angle slowly. Finding focus takes patience. Your homemade microscope won't be perfect, but it could still help you tell one mold from another or spot bacteria moving in water. Of course, it helps a lot if you already know what Penicillin mold, the one that makes penicillin, actually looks like under a microscope. Same goes for Staphylococcus, the kind of bacteria that causes many wound infections. The microscope didn't just change how we see the world, it changed what we understand. Louis Pasteur used microscopes to prove that microbes, not miasmas, cause disease. Robert Koch identified specific bacteria behind deadly illnesses. Fleming saw mold-killing bacteria, and with that sight, antibiotics were born. From Van Leeuwenhoek's lens, to Lister's refinement, to your improvised island microscope, this tool has always been about one thing: turning the invisible into knowledge. On this island, survival doesn't just depend on instinct, it depends on science. The microscope gives you a way to test, to observe, to choose wisely. Even with primitive tools, it gives you a chance. Subscribe for more History Meets Survival Science adventures.